Let's explore sign conventions in this video. Basically, we're going to talk about the rules that we're going to use to apply positive and negative signs to measurements. Now, you may be having a lot of questions in your mind, as in what measurements are we talking about? Why are we applying signs suddenly or all of a sudden? And where are we going to use them? So what we'll do is we'll first look at what the rules are, then we'll look at some of the examples, and then hopefully it'll kind of sort of make sense why are we talking about it and where it's going to be useful. And one last thing before we begin, although in this video we're only going to talk about mirrors, if you are watching this video while studying about lenses, then the same rules are going to be applied even for lenses as well. Just wanted to clear that out. And by the way, if you are not studying lenses or you haven't studied them yet, don't worry about it. So let's start with the rules. And to understand these rules, let's take one example. Let's say we have a concave mirror with us. And by the way, this is called as a concave mirror because the reflecting side is forming a cave. So what are the rules now? Rule number one is that all the distances are measured from the pole. Recall what pole is? Pole is the center of this mirror. Now, when I say all distances, honestly, there are only three distances. One is the focal length, how far the focus is. Then object distance, how far the object is. And the image distance, how far the image is. All the three distances are measured always from the pole. That's rule number one, which I will not write down. Now, rule number two is, when you measure these distances can be measured either in front of the mirror or it can be measured behind the mirror. To give you an example, images. Sometimes the images will be formed in front of the mirror, and you may have seen that sometimes it can be formed behind the mirror. So to differentiate between the two distances, we're going to call one of this measurement as positive and the other measurement as negative. So the second rule is to figure out which distances should we call positive. All right, and let me write this down. The rule is we always choose incident direction as positive. So incident direction is always chosen as positive. So what do we mean by this? Well, if we come back over here, notice that because this is the reflecting side over here, the incident light will always be to the right side. Because, you would keep an object over here, notice where the incident ray would be. Incident ray, if you were to draw any, would always be to the right. And so since incident direction is positive, in this example, right side is positive. And what do we mean by right side? Right side of the pole, because all measurements are done from the pole. So any measurement which is towards the right side of the pole, in this particular example, will be positive measurement. And any measurement which we'll do to the left side of the pole will be negative measurement. So to take an example, imagine we are given the focal length of this mirror as 2 centimeters. Everything is in centimeters, let's say. There's an object kept at 3.5 centimeters from the pole. And let's say once we draw ray diagrams, we figure out that the image is formed at 5 centimeters from the pole. These numbers may not be accurate, I don't know, but just take an example. Now, let's assign signs to them. Let's start with the object distance. Notice that the object is lying on the negative side. Therefore, this object distance would be negative. Similarly, look at the focus. The focus lies on the negative side of the pole. Therefore, this focal length would be negative. Similarly, look at the image. The image lies also on the negative side. So here, the image distance would be negative. All right, let's take one more example. And it would be great if you could pause the video and see if you can try this yourself. So just pause the video and apply signs to these three distances. Remember, incident direction is always chosen as positive. All right, so incident direction is taken as positive. Over here, this is the reflecting side and our object is over here. So the incident rays will be towards the left. Therefore, you start from the pole, and all the measurements to the left are considered as positive this time. Does that make sense? Because our incident ray is to the left. And all the measurements to the right side now will be negative. And so the object is on the negative side. So it'll get a minus sign. The focal length, however, notice is on the positive side. The focus is on the positive side, so this focal length is positive. And similarly, if you look at the image, it's on the positive side, so that image distance would be positive. All right, now there's one more rule, and that rule has something to do with heights. Sometimes when you consider objects and images, the heights will be above the principal axis, and sometimes the height will be below the principal axis. Again, to differentiate between them, we're gonna call as one of them as positive, the other one as negative. So again, the rule that we're gonna follow over here is we're gonna choose above principal axis, or I like to just say up is positive. All right, so if there's any height which is above the principal axis, we'll call it as a positive height. And if there's any height below the principal axis, we'll call that as a negative height. So if we knew the height of this object, I don't know, maybe say the height of this object was 5 centimeters, then that would be a positive height. All right, and whatever is the height of this image, that would be a negative height. I'm pretty sure over here you can understand this. Since this object height is above the principal axis, it would be a positive height, whatever the height is. And look at the image, again, the height is above the principal axis. This would be a positive height as well. And that's it for sign conventions. So we have 3 rules. All the distances are measured from the pole. Then you start from the pole and you go in the incident direction, that's chosen as positive. And when it comes to heights, any height above the principal axis is chosen as positive. And by the way, this rule is given a name, this particular convention that we are following. It's called as the Cartesian sign convention. Cartesian signs. And the word Cartesian might remind you of a graph. And the reason behind it is because that's what we do in graphs as well, right? In graphs, we start from the origin and we choose the right side usually as positive, left side as negative, upwards as positive, downwards as negative. That's basically what we're doing over here as well. We're treating the pole as the origin because we're measuring all the distances from the pole. And instead of choosing right side as positive, the only difference is we are choosing incident direction as positive. That's it. But pretty much everything else is the same as graphs. That's why it's called the Cartesian signs. Now, one small thing is that in some textbooks, they follow this a little differently. It's pretty much the same. So the only different thing that they would do is while drawing the diagrams, they will always make sure that the incident direction is drawn to the right. Okay? They will always make sure this is true. Then automatically the right side will always be positive. All right? For example, they would recommend never to draw like this, because over here incident direction is to the left. They will always recommend you make sure that your object lies on the left side of the mirror. So we have to flip this whole image. So basically they say that, you always draw in such a way that the incident direction is to the right. All right. And then we can always choose right side as positive, which is what we do usually in any graph. So it's more aligned to the graphical system. Okay. Now you can follow that obviously, but in general, what I like to remember is you draw however you want, just take incident direction as positive. So anything you can follow, it's pretty much the same thing. So the last thing we'll talk about is why do we even consider signs? And for that, let's take an example where we have already done this before. So an example of things falling under gravity. You may recall that whenever things are falling under gravity, usually when an object is falling down, we would say its velocity is negative. And when it's going upwards, we would say its velocity is positive. If we didn't use that sign, we might have to explicitly say in English that velocity is downwards and velocity is upwards. But we don't like that. We want to reduce English and use maths as much as possible. So signs tell us what direction the ball is traveling mathematically. And the idea over here is exactly the same. Without signs, we have to explicitly mention we're dealing with a concave mirror or a convex mirror, or the image is in front of the mirror or the image is behind the mirror. But with signs, these things are done mathematically. For example, if I just say negative focal length, it automatically means it's a concave mirror. Positive focal length, convex mirror. If I say the object distance, or let's say the image distance is negative, automatically it means it's in front of the mirror. It's positive, automatically it means it's behind the mirror. So long story short, signs help us differentiate between the directions in which we're doing the measurement mathematically.